Hey everyone, I hope you guys are doing well. Today we're going to be breaking down one of the biggest ideas in calculus, which is called derivatives. We're going to start from limits, understand what a derivative really means, and then we're going to learn the main rules that are used to calculate them quickly, which makes the equations more simpler, like chain rule, product rule, and quotient rule. So let's get going. So first up, we're going to ask ourselves what a derivative really means. And we're going to see what's happening on the screen right here. So over here we can see that a car is moving and its speed is changing. So we can think of a derivative as measuring how something is changing at a precise moment. And basically if you're driving, the speedometer shows your instantaneous speed, and that's basically a derivative. And in maths, if we have a function like f of x, its derivative will tell us how fast f of x is changing as x changes. So next up, we've got limits. And to understand limits, basically to understand derivatives, we need limits. And a limit tells us what value a function approaches as x gets close to something. So we use limits to define a slope at a single point, and that slope is the derivative. So basically here's the idea. The average rate of change is the slope between 2 points. But if we move those 2 points closer and closer, the slope becomes the instantaneous rate of change. Instantaneous rate of change. And basically that's the derivative. So now we're going to talk about continuity and differentiability. So on the screen we have a smooth curve and a not so smooth curve. So for a function to have a derivative at a point, it needs to be continuous, meaning basically no jumps or holes in the graph. But continuity alone isn't enough. If there's a sharp corner, the derivative doesn't exist there as well. So we need smoothness as well. So over here we're going to be talking about the derivative rules. It is a very important aspect of this chapter. And first off, we're going to be talking about the power rule, which we can say is probably the easiest rule out of all. So it's basically like this. Suppose I have x and the power is n, so its derivative will be n multiplied by x minus the power 1. So for example, if we say we have 5x3, its derivative will be 15x, power is 3, so minus 1, it's 2. That's the answer. So next up, we're going to be doing product rule. So it happens when two functions are basically being multiplied. So suppose mn, we have to find their prime, it will be m prime n plus n prime m. So we're going to do an example. It will be, let's take f of x is equal to 2x square multiplied by 3x minus 1, and now we have to find the derivative. So to do that, list out our values. M is 2x square, m prime is 4x, n over here is 3x minus 1, so n prime would be 3. Now we just have to substitute the values. When we substitute the values, it will be 4x 3x minus 1 plus n prime is 3 multiplied by 2x square, and then after that you just have to simplify it, which will be 12x square 12x square minus 4x plus 6x square. That's it. That's product rule for you. So next up we have quotient rule, and we go for quotient rule when one function is getting divided by another function. So suppose if y is equal to m over n, and if we were to find the derivative of the y, so y prime would be m prime n minus n prime m over n square. And over here the order of the m and n matters a lot, unlike product rule. So let's do one example. So y is equal to 3x square over 2x square. So m is 3x square, so m prime would be 6x, and n is 2x squared, so n prime would be 4x. Now we just have to substitute the values, which is quite easy. So n prime is 6x multiplies n, which is 2x squared, minus what is n prime, 4x multiply 3x square, or 2x squared power 2, so it would be 4x 4. And after that you just have to simplify and you get your derivative, you get your y prime. So last up on the list we've got chain rule, and this rule is for functions that are inside other functions. So we differentiate the outside, and the inside we keep the same and then multiply by the derivatives of the inside. So we can understand it by doing an example of it. So for example, f of x is equal to 4x squared minus 3 power 5. So let's take to find the derivative, we're going to do f prime x, and we're going to substitute the values. So it's going to be u power 5. So 5 u power 4 multiplied by the u prime. That's how we do it. So it would be 5 4x squared minus 3 multiplied by the derivative of the inside, which would be 4x squared minus 3. It would be 2 multiplied by 4, it would be 8x. That's our final answer. That's how you do chain rule, which is quite easy.